The first principle of animation to master is that of timing. Timing is more than just how fast or how slow something is animated. It really deals with the pacing and the spacing of the objects and how they're presented onto the screen. The personality and nature of an animation is greatly affected by the number of frames, the number of drawings that are inserted between major actions. First off, timing deals a lot with the spacing of your animated objects. If we have a ball moving from one side of the screen to the other, it's going to travel that distance in a certain amount of time. That time is determined by the amount of space that's divided up. For instance, if we have a lot of spacing and they're very close together, it's going to take more time for it to travel from one side to the other. So it's going to give the illusion of slow movement. However, if we were to space these out farther, taking up less pacing, but it will take up less time. In this case, moving much quicker. So you can see the two major differences, and this is fundamental for how you move your objects on the screen. More frames relatively equals a slower time or a slower speed, versus fewer frames will give you a faster speed. But in addition to spacing, timing can also be used to determine the pacing of when an action happens within a scene. So let's say you have a scene with the ball bouncing from one side to the other. Pacing is when the major events happen. In this case, it's when the ball hits the ground as it's traveling along. Animators would take note of when these key moments happen, and then they would space the ball appropriately to match that action at that time. This is how spacing and pacing work together to build your animation. Finding when those key events happen is known as key framing. So in this case, the animator would determine it takes 5 frames for the first bounce, 10 more frames for the next, 13, 10, so on and so forth as it travels along. They can then place the ball right where it needs to be and test the timing of how that animation moves. Now right now, our animation looks very clunky. They would then go back and place all of the in-between frames in between the main keyframes. From there, they could refine it even farther to see what this would look like. Still looking very clunky, but if it does tend to time out correctly, they would go back and repeat this process until all of the frames are animated, giving you your final animation. Let's see what timing does when you break down a walk cycle. Now, walk cycles are whenever you animate a character or an object walking as they would naturally. There's a lot of moving parts to this. You've got the feet moving, his hips are moving, and his shoulders are swaying back and forth, causing his arms to sway. Even his head has some movement to it. But within a walk cycle, you break down the timing by what the feet are doing. The first thing we want to determine are what are the two extreme poses. Since he's doing the same thing over and over again, we only want to animate it going from one extreme to another and then repeat the process over again. On the first extreme, his left foot we see is making contact with the ground, and his right foot is being picked up. Now, since this is going to repeat itself, by the 40th frame, the very last frame, we want it to be doing the same thing, having the left foot making contact and the right foot being picked up. Now, in between this, we know halfway his right foot should be making contact, and his left foot should be picking up. So at frame number 20, halfway on our timeline, we draw halfway through the cycle. We can then repeat this process again. So between frames 1 and 20 is frame 10, halfway of our timeline. We'll have the right foot passing through, and then by frame 30, it'll be the left frame making a passing move. You can then repeat this process over and over again, not just applying it to the feet, but to applying it to all of the body's movement and motion, until you've completed the entire animation, walking from one side to the other, and then repeating that cycle. Finally, let's look at timing and pacing within an entire scene. Let's say you have a script that calls for a person to walk onto the stage, pick up a piece of chalk, and write on the chalkboard. An animator would break this down at first by its key events: walking in, picking up, and writing. Then you can determine how much time you need to perform each of these actions. By the first frame, him walking in, it should take about 3 seconds to reach and pick up the chalk. That'll be about 75 frames. And then a few seconds later, he's writing on the chalkboard. The whole thing lasting 5 seconds or 110 frames total. Next, you can break down all of the in-between frames between each of those key events. All of the walking cycles, bending down, picking it up, and then writing. And then finally, repeating that process until the entire motion of the animation has been drawn out. You can see that it takes a lot of animation just to do a few seconds, but all of this is critical to be perfectly timed and paced out and spaced appropriately in order for it to look like lifelike motion. Here's some additional things to note. Typically, one animator doesn't have to animate everything within a scene. It's usually the job of the senior animator to draw the key frames within a scene's action. They then give it to the junior or assistant animator to animate all of the in-between actions in between those key frames. Also, you don't technically or typically have to animate every single frame. This is known as animating on the ones. It's very time consuming, so to save time and money, studios usually animate on the twos, meaning they'll draw something every other frame. This still gives the illusion of animation and life, but it saves a lot of time and money and hassle rather than drawing every single frame. Alright, next, let's do a demo on timing.